All right, so in this video, as promised, we're going to take a look at how to create the main web, the main threads. It's kind of ugly right now, but bear with me, we will add like other layers of threads and the simulation will do a lot. So let's dive right into this node. What's happening in there is that we're creating a border group made from the uncharted edges. We're converting it to lines, then blasting everything but the lines and resampling everything. On the other side, we're giving the, the geometry a bit more subdivisions. Before going to that part, I need to explain what's going here in the parts actually. So we are taking our smooth geometry and our borders. We're giving our borders an emit value of 0. We're giving a bit of, UV textures and rest position. It's not mandatory, but it's always a good practice. We're clamping the previous values and transferring the 0 value from the edges to our geometry. And what we're doing is actually, this one is useless. And what we're doing is like multiplying what we had here with what we had at the beginning. Okay, so it's a bit tedious, but you can do whatever you want here. You can also paint the attribute if you want to. Just keep in mind that at that point you have to have an emit value with 0 value probably on the edges and higher values when you want to have like higher point count or point density and stuff. What we're taking here is like the curves that we drew before, and giving them an emit value of 0.5. Sorry, I just 0.5. And what we're doing is transferring this value onto our geometry. Okay, so now I need to go back here a bit above. We have our geometry. We are creating a bound node to have like, the bounds of this geometry. And these three nodes, four nodes actually, they're selecting the largest, one of the largest polygons. It will help us because the Voronoi fracture, if I show you like right now, the Voronoi fracture works perfectly on a flat surface, but it doesn't on a curved geometry. So that's actually what we're doing here. We're measuring the area, promoting to this geometry the highest, the biggest area, and only keeping the geometry which has the largest area, and deleting one of them. It will always be, you will always have just one polygon. Okay, so now we're taking this geometry with the correct attributes and we raying that on that flat surface. And now, because you need to give the points to the correct location, because otherwise if we wouldn't do that, we'd have, it could also work, but it would be less precise. So you need to have in that case it doesn't change a lot, but it's because our plane is not really, it's not it's almost flat. You have a bit of, curvature, but it's not a lot. So that's just good measure. So anywhere scattering the points from our emit attributes. And yeah, we're voronoying, if that's a word, everything. And what we're doing right after here is just a way for you to keep or not keep the edges. It can be sometime more organic, not to keep the border, not the edges. I mean, the edges is kind of the same. You can choose to keep or not the borders. And now what we're doing is we point deforming this geometry to the initial geometry that we had before. Great. And what we're doing next with these points is another voronoi, but it's actually not fracturing our geometry, but linking all the points together. It gives another extra layer of threads. And what's happening here is we are creating a bit more, you have like several layers on top of it. It can get really messy sometimes. I'm not using it in the end, but just, keep in mind that you have that option. And same thing for this part. You can also have different layers. So you would add, multiple poly extrudes and you will end up with layers. But I'm not using that anymore. So yeah, if I enable it, you would have several layers, but they would not change. So maybe that's not what you need, but it gives a bit more of a depth feeling. Um, we're merging everything together, resampling it so everything has the same uh, point distance, not point distance, but point distribution onto the lines. And now what we're doing is we're taking back our smooth geo and raying um, our um, our threads onto the geometry, just to be sure that it fits correctly. So you can see it doesn't change a lot because we already point deforming it, but it's changing a bit. And now what we're doing is we're taking the curves, resampling them a bit, and then we're attracting from we attracting the threads to these curves. It's not really complicated what happens inside. I just put them inside of the node so we have like, all the controls uh, at the same um, place. So what we're doing is actually pretty basic. We're resampling it. And what we're doing is like storing from every point here in this geometry, we're storing which is the closest points of these curves. And we're storing these attributes called near position. We're calculating the direction from the points from the thread to the curves. We're creating a distance attribute, and based on the distance, we're attracting our points by adding the direction times the distance. And that's what we end up with. It's actually kind of the same with the repel. It's kind of the opposites, but we just have to go through some steps before. So we are resampling our curves, giving them a connectivity attribute, a class attribute, creating some normal and tangent V attributes, and now we're going into the loop. So we're gonna take each curve, fusing it so it's, even if it's kind of ugly right now, it's fused so it's closed. Because if we don't do that, we can't really close it after. We're gonna thicken it a bit in both directions, as you can see, and polyfilling it, giving it some normals. And now we're gonna convert this into a VDB, and we're doing that for every curve. Now what we're doing is like creating a group from the points that we have from the geometry that we just created onto the initial geometry, and then either blasting everything or repelling. And it's actually doing the same thing as we have before, just using the bitangent. And basically, it's kind of the same thing. So you can choose to repel or not the points. All right, so you have the option to just, delete or repel. And we're giving some normals and transferring back the groups that the borders, which we call static, because in time these points will be static and everything inside will be simulated. And yeah, that's what we end up with. Some threads here. And actually, I'm gonna go back to just repelling because I prefer it a bit more. So that's it for this part. Next, we're gonna take a look at how to create other interesting threads.